Let's take a look at an example here. So it says to solve for k, and it gives us some information. It says that when 2x to the fourth minus 5 is third, 2x squared plus kx plus 5 is divided by x minus 3, the remainder is 4. And they want us to find out what this value would have to be for k. All right, so some things we know in this unit we've been studying remainder and factor theorem. Okay, and so what the remainder theorem tells us is that if the remainder is 4, okay, that means that if we divide x minus 3 into this polynomial, the remainder is 4. It also means that we can use synthetic division. Okay, if we use synthetic division with x minus 3, the last value in the synthetic division will be 4. And we're going to use that fact to solve this problem. Okay, so if you don't remember synthetic division, go back and take a review. I'll go through the steps here, but if you have trouble with that, you might want to review synthetic division. So with the synthetic division, you take the polynomial you're dividing and you write down just the coefficients. The first thing you want to do is make sure it's in order. It is. It's the fourth power, third power, second, first power, and then the constant. None of those were missing, so I know I don't have to place any zeros as placeholders. So we just write down the coefficients. So we have 2, and then leave a space, -5. The next coefficient is 2, and then k, and then 5. Now I'm dividing by x minus 3, but when you do synthetic division, you do the 0 out here. So if x minus 3 is divided, when I do synthetic division, you set that equal to 0 and solve, and we're going to be using 3 for our x. So right here, I put the number I'm dividing by, which in this case is 3. With synthetic division, you drop the first number straight down, so I'm going to drop the 2 straight down, and then you multiply. 3 times 2 is 6. You place that underneath the next number. And then you add. -5 plus 6 is 1. Then we multiply again. 3 times 1 is 3. You place that under the next number. Then you add. 2 plus 3 is 5. Then we multiply. 3 times 5 is 15. You place that under the next number. And then you add k plus 15. Well, they're not like terms, so I can't combine them. All I can really do at this point is write k plus 15, because once again, they're not like terms. Multiply 3 times k plus 15. Well, I'd have to take the 3 times both parts. So 3 times k is 3k, and 3 times 15 is 45. So I get 3k plus 45. And then I'm supposed to add straight down. Well, I have 5 plus 3k plus 45. I can add like terms. The 5 and 45 do not have a variable, so they can be added together to give me 50. So I get 3k plus 50. Now, I was told that when I divide x minus 3 into this polynomial, the remainder was 4. The remainder would be this value right here. So we know that 3k plus 50 should equal 4, and we're going to use that fact to solve and find out what k should have been. So now we just have to solve this equation. So I subtract 50 from both sides, and I get 3k equals -46, and I divide both sides by 3, and I get k equals -46 over 3. Not a very pretty answer, but it is the correct answer. So the number that should have been here is -46 thirds. All right, we're going to do a second example here. So you can pause and try this on your own and then press play to check your answer, or you can just follow right along, whichever works best for you. So once again, we're given the same type of problem. We have a polynomial, but one of our coefficients, we do not know what it is. We're just calling that k. We know that if it's divided by x minus 5, we end up with the remainder of 5. So our goal here is to use synthetic division. And in synthetic division, we know that whatever value we get on the end here is our remainder. So whatever value we get here, we know should be equivalent to 5, and we'll use that fact to solve for k. Again, you set up your polynomial, make sure it's in order. So I have an x to the third. X squared should come next, and there is not one. So we replace that with a 0, x squared. Okay, then an x to the first power we have, and a constant we have. We write down our coefficients. So we have 3, and then 0, and then k, and then 5. We're dividing by x minus 5, but remember with synthetic division, we want to set that equal to 0 and solve so that we know which value to put outside of our synthetic division. In this case, that would be 5. All right, so let's get started. We drop the first number straight down, and then we multiply. 5 times 3 gives us 15. And we add 0 plus 15 is 15. And we multiply. 5 times 15 is 75. We write that directly under the next value. And we add. Again, k and 75 are not like terms, so we cannot combine them. All we can do is write them as k plus 75. We multiply. 5 times k plus 75. Well, 5 times k gives me 5k, and 5 times 75 gives me 375. And we add straight down. Again, the 5k can't be added to 5 because they're not like terms, but 5 and 375 can be added. So I get 5k plus 375 plus 5 is 380. Okay. Again, our goal in the end was to take this value, which is the remainder, and we know that it should equal 5. So we take 5k plus 380, and we set that equal to 5, and we solve to find out what k is. I would subtract 380 from both sides. Gives me 5k equals negative 375. Divide both sides by 5. And I get k is equal to negative 75. Okay, so I know in this polynomial, this value of k would be a minus 75.